Alright, today we're talking about angles of elevation and depression. Objective, I will learn to solve problems involving angles of elevation and angles of depression. So I'm going to give you this picture. The important thing to remember is that the angle of depression and angle of elevation are equal. And that's because the way this is drawn are these horizontal lines are actually parallel to each other. So we create these alternate interior angles. Right, and so this would be the line of sight, which is going straight across. And so when you're looking up, that creates this angle of elevation. Now, if you're on the top looking down, that creates this angle of depression. Right, and then we would assume, or we make the postulate that this is going to come down straight at a 90-degree angle. Okay, so angle of elevation, you're looking up. Angle of depression, you're looking down. All right, so let's look at the first example. The Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the Space Needle is 7 degrees, how tall is the Space Needle? Round to the nearest meter. So we're creating this right triangle, right, which means we're going to be able to use our trig functions. So this is our kind of our reference angle, this angle A. So from the 70, the y is going to be opposite, and the 67 is adjacent. So if I want to figure out what this y value is, I'm going to use the tangent function. So tangent of 70 is equal to y over 67. Multiply both sides by 67. And again, you make sure your calculator is set to degrees. And so we did 67 times the tangent of 70. And so y is going to be to the nearest meter, that's going to be 184 meters. Okay? Alright, next example. If I have an airplane, so this point P is my airplane, and the angle of elevation is 41 degrees. What's the horizontal distance? That's the x right here between the plane and the airport. So this would be my plane. P for plane, A for airport. All right, let's see. So again, this A is my reference angle. So from the 41 to the 35, that's the opposite. And the x is going to be adjacent. So again, that's the tangent function. So tangent of 41 is equal to 3,500 over x. All right, multiply both sides by x. And x is going to be equal to 3,500 divided by the tangent of 41. Okay, so rounded to the nearest foot, that gives me 4,026 feet. All right, example 3. All right, an ice climber starts at the edge of a crevice that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 feet. How deep is the crevice at this point? Okay, so a crevice is just like a ravine or a cliff. So if the person is here, and then there's this kind of edge over here. All right, so this distance from here to here is 115 feet. Right? And they're looking down this way. The angle of depression is 15 feet. So from here to here, that's, excuse me, 52 degrees. All right. So if this angle is 52, then this angle down here is 52. All right. How deep is the crevice? So that means this right here is going to be my x. All right, so again, that's going to be opposite the 52 and adjacent, because this would be my right angle. So the tangent of 52 is equal to x over 115. So to solve for x, we multiply both sides by 115. I'm going to need to round this to the nearest foot. And I get that that is 147 feet. All right, next question. Suppose a park ranger sees a fire from the watchtower and the angle of depression is 7. From the top of the tower to the fire is 7 degrees. What's the horizontal distance to this fire? So again, if this angle here is 7 degrees, then this little angle over here is going to be 7 degrees. Right? And we want this entire distance from the station to the fire. So, again, that's going to be opposite over adjacent. So, again, that's tangent. The tangent of 7 is equal to 90 over x, which means x is going to be equal to 90 over the tangent of 7. And that means x is going to be about 733 feet. All right. Number 5, an observer in a lighthouse is 69 feet above the water. So if I have a lighthouse, and this distance from here to here is 69 feet. The angle of depression to a boat. So over here somewhere there's a boat. Don't judge my boats. So I'm looking, here's my normal line of sight. I'm looking down 48 degrees. So if we kind of make this a straight line, this is my 90-degree angle. This is 48 degrees. All right. Then there's another boat out here. So I'll call this first distance x. This next distance over here, from here to here, is going to be y. All right, the angle of depression to the other boat, so there's another boat that's coming down this way. That angle is 22 degrees. What's the distance between these two boats? So this point, I can call that z. All right. So I would need to subtract x and y to get z. So, for this first boat, the tangent of 48 is going to be equal to 69 over x. So x is going to be equal to 69 divided by tangent of 48, which comes to be about 62 feet. Then we need to find the distance of this second boat that's further out. And that's going to be tangent of 22 is equal to 69 over y. So y is going to be equal to 69 over the tangent of 22. Excuse me. So y comes out to be about 171 feet. Right, and then to find this distance z, I'm going to need to take, let's do it up here, 171 minus 62. And I get that this is 109 feet.